Okay, let's get started. Hello, everyone, and welcome to the Daily Space for Wednesday, October 10th of 2018. I am your host, Dr. Andres Plazas, and let's talk about astronomy and space. As you know, we've been a little bit busy. Dr. Gay and myself, we've been traveling a little bit. Pamela is in Australia, and I was in Washington, D.C. for a meeting, and I'm going to talk a little bit about that in our second story of the day. But first, we're going to talk about the Hubble Space Telescope. And as many of you know, Hubble has entered a safe mode because the gyroscope has not been working properly. So NASA is actually working to resume the science operations of the Hubble Space Telescope after the spacecraft entered in what we call the safe mode on Friday, October the 5th. So usually Hubble Space Telescope uses 3 gyroscopes in order to find where it should be pointing in order to detect the rate of rotation that it should have. And it was actually, when we had the space shuttle in the United States, it was actually serviced at the end of the 90s. This is not the first time that the gyros fail. But then we were able to send an astronaut, and then we could figure it out. And then actually, the Hubble Space Telescope had 6 gyroscopes. 3 of them were enhanced, and then the other 3 were the ones that were actually used to maintain operations of it. So it turns out that, recently, one of the 3 gyroscopes that were being used to point and study the telescope failed. And the good thing is that Hubble Space Telescope has multiple redundancies. What does this mean? That it actually, if one of the gyroscopes fails, then the Hubble Space Telescope can still continue working with the other 2 gyroscopes. So what's going on is that 2 of those gyroscopes are actually currently running, but what's going to happen is that the telescope is only going to be able to work with a limited capacity. So why do we need 3 gyroscopes? It's because we have 3 dimensions, 3 axes in space, in 3-dimensional space. And usually you need to know you have 3 degrees of freedom. You can call them the Euler angles, or just basically a 3 degrees of freedom. And if you lose one of the gyroscopes, then actually you can still have some movement, but these movements are going to be limited. Then again, as I was saying, there are a lot of redundancies built in not only the Hubble Space Telescope, but in many of the spacecrafts that NASA builds. So in particular, Hubble also has instruments that are able to measure the magnetic field of the Earth. So it is able to use these magnetometers to measure its position with respect to the magnetic field of the Earth. There are also instruments that tell Hubble where it is with respect to the sun, because of course we would need to know, if you're at the Hubble Space Telescope, we would need to know where the sun is. So in order to avoid having all the sun from the light from the sun falling in our instruments and actually damaging them. And then when Hubble, then a third mechanism that could be used is like when Hubble is pointing at a field. Actually, there are certain types of stars. There are different types of sensors that are used as guiding sensors, and then these guiding sensors locked into a particular type of stars with different magnitudes. And then once they have locked into these particular stars, then the tracking system, the star tracking system of the telescope is going to be able to maintain it pointing in the direction that it wants with a precision of the order of milliards. So there are, of course, these systems are not mainly designed to do what the gyroscopes were doing, but the bottom line is that even if we have one gyroscope, we are able to use the information as a complement, the information from these other systems as a complement in order to be able to actually do the pointings that are required. It might take a little bit longer. There might still be some places in space where you cannot point. But in general, the science operations of Hubble are still going to continue. Well, let's remember, we always have to remember that this is a telescope that is 28 years old, and actually it's way past its mission life. So, but of course, this is a telescope that has given us so much. So we are working hard to keep it going as much as we can. And in the meantime, of course, we're waiting for future space telescopes such as the James Webb Space Telescope, and yeah, we'll see. So that was the first story of the day that I wanted to tell, and the second story of the day was related to what I was doing back in Washington, D.C. So it turns out there was a call for this something that is called the Decatur Survey. So what is the Decatur Survey actually? This is a study that the agencies that fund the research of astronomy and astrophysics in the United States, these agencies commission the National Academy of Sciences to gather a group of experts in the field, to gather the whole community, to identify the big science questions in astronomy and astrophysics for the next decade. And this survey also should give priorities on the investments needed to maintain and strengthen the foundations of this astronomical enterprise that we have in the United States. So, for the Decadal Survey of 2010, the report was entitled "New Worlds, New Horizons in Astronomy and Astrophysics." You can find the whole document online. But it's like a 300-page document. Actually, I was able to grab a hard copy of the report because I had to read many of these reports in order to give this. But this is the point is like that this is a very important document because it's going to tell Congress, for example, what the priorities in astronomy and astrophysics for the United States should be in the next decade. So this is a process that has been happening since the 60s. There have been 6 decadal surveys since the 60s, and for this particular one, they wanted to gather input from early career scientists. And by early career scientists, we're talking about graduate students, we're talking about postdocs, people who have gotten their PhD after a certain amount of time, but they are not in a permanent position. And then those people who are still maybe in a permanent position, but they just recently finished their postdoc period. So yes, so okay, so this is a science-driven survey, first of all. And what are the big questions that we want to answer in such a type of survey? So we had a lot of discussion of this. So many of the questions that we have is like, what are other planetary systems like? How do stars and planets forms? What are black holes? What are the nature of what can we do with gravitational waves? What are dark matter and dark energy? What causes cosmic inflation? How has the universe evolved over time? So these are the types of questions that we were talking about, and then we were providing input to some of the representatives from the previous survey. And then one of the things that we were talking about is like, now, for example, that we have discovered gravitational waves. We are entering an age of what we call multi-messenger astronomy, where we can get the gravitational wave signal from an event, but at the same time, we can also get the electromagnetic signal from that same event, for example, when 2 neutron stars collide. We also expected that another priority for the next decade in astronomy and astrophysics should be the identification of exoplanets that have characteristics that are similar to our own Earth. So the direct imaging of an Earth-like exoplanet is one of the main goals or should be one of the main goals of astronomy for the next decade. And so I just want to be clear, the committee is about to be formed for the next decade. They just wanted to gather input from the early career scientists. And in the next months, the Academy should pick a chair, and then that chair is going to pick a committee with a lot of panels and different of experts all around the field. And then other topics that were discovered were the importance of big data in astronomy. We're going to have facilities such as the Large Synoptic Survey Telescope, LSST, that is going to gather an enormous amount of data. And we are concerned about if we have the facilities, we have the resources, we have the funding to actually deal with this large amount of data. So, of course, this is a science-driven survey, and those are the main priorities, and we want to answer these big questions, but then we also live in the real world. We are limited by budget. We are limited by the current policies of the administrations. So we need to actually try to identify what the priorities should be. So in addition of talking about the science, then we need to talk about the facilities that will allow us to do that science, and then what are the capabilities needed in order to achieve these goals. So it was a very interesting meeting. In addition to that, many of us made a lot of emphasis on the human aspect of the science, because this is a science that, of course, astronomy is being done by people, and there are a lot of pressing concerns that have not been addressed today. So we talked about, of course, the representations, the gender gap in astronomy, the representations of women and of women of color, the representations of minorities, different ethnicities. There have been multiple reports of sexual harassment. And these are issues that we also have to address, I think, and bring up in such a program like this. So there was discussion about everything and this kind of things. It was very interesting. And then the outcome of this meeting, we're going to write a white paper. We're going to write a paper where we're going to summarize all of our conclusions. This paper will be presented to the committee, but in addition, 3 of the attendants to the meeting will actually get the chance to talk in person with the chair and the panels of the committees. And hopefully this is a mechanism that will increase the participation of junior scientists into the policy of astronomy or of science. So this is, just to reiterate, this is a very important report. For example, many of the recommendations that previous decadal reports have done actually have happened. Like the Hubble Space Telescope was one of the priorities in one of the reports, the Spitzer Telescope. The LSST was the main ground-based priority of the New Worlds, New Horizon report. And for space, the main priority was WFIRST, who was identified a mission that could tell us more about dark energy and in addition tells us more about exoplanets. And as I said, this is a report that has a lot of influence not only in the United States but only in the world. The United States is still leading the research in the world, although of course many other countries and many other agencies are catching up. So we need to keep working to maintain the leadership, and we need to actually do investment in order to keep this leadership. Just to put things a little bit into context, for example, the ESA, the European Space Agency, they also have their own surveys. They have their own reports. One of them is called Cosmic Visions, if you want to Google it. And then you can see that they also identify their own priorities. But then, as we were talking about, I think in a previous daily space, many of these agencies, they work in coordinations. Although sometimes there are the differences where every agency or every country, they want to lead their own project, of course. Nobody wants to be like the second to the first when leading a project. And one example is the dark energy missions. The United States is leading WFIRST, but then the European Space Agency is leading a dark energy mission based on space that is called Euclid. So they are complementary, but at the same time, one could argue that there could have been a better coordination in order to better spend the resources. So, of course, this is not a trivial topic, but it's something that is very important to talk about and to consider. Okay, so yes. Um, yeah, I wanted just to show you some of the goodies that I got from the national academies. Then I have a lot to read from the actual reports of the panels. So it's a lot, but this is actually a very good summary of what the state of the profession is. And it's something that is very well recommended to people who are studying astronomy. And one of the things that I wanted to share with you, a document, I found a PDF document that actually summarizes very well the hundreds of pages of the Decatur Survey. In case that you want to look at it, I'm gonna post it in the chat. This is a PDF where if you spend a few minutes, then it's very well done, and then you can find out actually the questions that we were trying to be answered, and then the priorities that were identified for this New Worlds, New Horizons survey. Okay. So I wanted to tell you about that, and because I think it's very important and relevant, and I'm gonna see if you have any comments. All right. So hello, Guido, Susie. It's already Wednesday, Guido. That's true. Hello, Larry. Hello, Graham. Phoenix. Hello, Tom. And who else do we have? We have the Nightbot. Very nice Nightbot. So Hani's asking, could they find a weird way to stabilize it, like they did for Kepler? Well, actually, the weird ways to stabilize it, a weird way is a non-canonical way, and the way that they already have in plan is using this the star tracker, using the sensors from magnetic field, and this is actually the plan B. This is how they're going to do it. It's already weird because we're doing like workarounds. We're using instruments that were not explicitly designed to do this, and actually after the survey mission survey, it was the survey mission number 4 at the end of the 90s. A few years later, then engineers started to thinking, okay, the gyros already failed, so now we need to have a plan if the gyros failed. And then there were papers published with algorithms and with procedures on like, what do we do if one gyro fails? Then we're gonna use this other instrument, and this other instrument in order to work around that. So Larry's asking if they can point Hubble, how do they point the antenna to the Earth? Oh, if they cannot point Hubble. Well, they actually still can do it. I mean, maybe what's happening is that it's not that we cannot point anymore, it's that we cannot point to the precision, to the high precision that you could point when you have 3 gyros. So you can still do, the gyros are actually detecting the rate of rotation and is helping you to figure out how to point your telescope. But you can still, the telescope is still working. It's just, and as I said, there are mechanisms using complementary systems in order to do the appropriate pointing and rotations. We might not be able to point it with the same accuracy that we had. That's one thing, but we're still able to keep working with the Hubble Space Telescope. So the James Webb Space Telescope, we are not getting any younger. That is true. This was one of these. James Webb Telescope is going to be a superb telescope and is going to give us a lot of new science. But when you come to the real world, actually, it has hurt a lot the fact that we have not been able to launch it because the NASA cannot start new projects until we're actually done with it. So this is something that, for example, the Decatur Survey in 2010, they were counting on James Webb of being launched, but things happen. There are things that we cannot anticipate. And then it's, of course, very hard to predict the future. And then, of course, the budget that is being allocated for James Webb then is preventing from other missions to go, and it's just the way things are. But yeah, I mean, in the future, well, of course, now NASA, of course, is implementing more stringent measurements in order to um, control the budget. The budget to begin with is a very infamous part of the whole federal budget. So I think that they should just give us more money and end of the problem. But given the current constraints, as I have mentioned before, one of the things that happened in the previous year is that the presidential suggested budget was suggesting Congress to cancel W first. In the end, it didn't happen. But it was a consequence of having like all these constraints on the budget, and these are all the things that must be taken into account and of course studied when you're planning for the next decade in astronomy. Will Hubble eventually be deorbited, or will it just be in orbit until it finally falls? So I think people are still talking about it, and there are some people are actually advocating for Hubble not to be destroyed and maybe deorbited in a controlled way, so people can put it in a museum or something like that. But then there are other people that are saying maybe you can push it into an orbit that could bring it closer or parallel to the International Space Station, and maybe it could be serviced. And then another people who say maybe you can just push it to an even higher orbit when it's all gone and you cannot do anything, just put it in a storage there, like, so maybe in the future we could retrieve it. But then, of course, what it comes down to is to budget, to money. Do we want to spend the resources? Is there enough public support to spend the resources in bringing back Hubble in a safe way? Otherwise, of course, they're just gonna probably deorbit it in the middle of the ocean. Of course, if you're gonna deorbit it and you're not gonna keep it, you still have to make sure that it's in a safe way, right? So it's probably gonna end up in the middle of the ocean. So people have not decided yet. It's going to depend on what the political or the current budget situation is by the time when this happens. But there are options, right? And these are some of the options that people have contemplated. Would the mirror survive reentry? That's a good question. Sorry, that's a bug. That's a good question. I'm not quite sure, but it's one of the things that you have to consider with the friction of the atmosphere and how do you bring Hubble safely, and that's definitely a concern. Of course, you're going to have all this friction and all these temperature changes with Hubble, which was designed, of course, to go up in a capsule, but then to go back. How do we bring it safely to keep everything? So that's not entirely clear. And then again, this is an investment of resources, and then people have to decide whether it's worth it or not. Have they thought about doing outreach to the public during eclipses and other astronomical events to get different people interested in science? Yes, absolutely. And one of the chapters in the decadal report is talking about the impact of astronomy on society. So it is definitely something that is talked about, education and public outreach. And it's something that is very important, in my opinion. And what I think is that in the next decadal survey, it should have a higher priority, and there should be items of action in order to invest more in this. Then again, we come back to reality. And usually when people or when NASA or where the administrators do need to make budget cuts, unfortunately, the first place where they're going to look at is at education and public outreach project. So this is definitely a topic that is being considered and being talked about, but in my opinion, it should have higher priority. And in the end, when you have limited resources, in the end, it's a matter of priorities. So I do have a higher pitch at home than over the office. That might be true because I'm using a different equipment and maybe the acoustics of my house. I do think it's the microphone. And in the past, I've used some microphone, the one that Dr. Gay uses, but that was a fancier microphone, and I don't have that one here. There seems to be Hurricane Michael on the way, so please stay safe for some of you. I hope nothing happens. And all right, so do you have any more questions or any more comments? They shouldn't cut public outreach. I know people who thought NASA had shut down. That's terrible. I didn't know that people could think that, but I absolutely agree with you, Hani. There should be a large investment in public outreach. I believe, and this is a personal opinion, that as scientists, it is our moral duty to give back to society on everything that we find, and to try to communicate this excitement of science and astronomy to the public. And then beyond the moral duty, I do think that it's an economic duty because a lot of the research that scientists do come from public taxes. So it's you who are paying for our research, for most of our research, through the National Science Foundation, through the Department of Energy, through NASA. And I do think, just to finalize, that of course we need more science education in general, and astronomy has historically been a gateway science, as people like to say. And it's not that I want everybody to become a scientist or an astronomer. I do want everybody to think critically and to listen to facts and evidence before making choices in their lives, and choices also that will affect other people, like when voting. So yeah. All right, everyone. So that was our show for the day. Thank you so much for tuning in. And thank you so much for your patience, because we have been traveling a little bit. Next week, I will be traveling to Cerro Tololo Observatory, to the Blanco telescope, for the Dark Energy Survey. So I may or may not come back. Hopefully, Dr. Gay will be back by then. And but who knows? Maybe I will get the chance to do the daily space from the telescope. So that would be cool. And well, thank you so much. And this has been the Daily Space, a production of CosmoQuest. Please give us a like and subscribe. Every support that we get from you is very important. And the Daily Space is brought to you, as I said, by CosmoQuest and the Astronomical Society of the Pacific. Okay, everyone, have a great day, and bye-bye.